Good morning students. I am Usha, Professor, EEE Department, Dayanand Sagar College of Engineering. Yesterday we have started with solving a given circuit using nodal analysis. Let us try to recollect what we have done in the yesterday's class. Suppose you are given an electric circuit. First what we have done is we have identified number of nodes in the circuit and then we have made one node as the reference node. Now let us try to apply the nodal analysis to different types of circuits. Yesterday we have seen only with current sources and voltage sources between two independent nodes. Let us try to see different cases. Now consider this circuit. This is an electric circuit. Now let us see how many nodes are there in this circuit. Now this is one node where 10 ohms, 20 ohms and 100 volt source are connecting. This is node 1 node. This is second node, this is third node and this is the fourth node, this is fifth node. So total we have 5 nodes in the circuit. Out of these 5 nodes, one node we have to make it as the reference node. Which node do you prefer to make it as a reference node? We can select any node as the reference node as I have mentioned in the yesterday's class. Now let us try to make one node as the reference node. Let me say this is my reference node. And this is node 1, node 2, node 3, node 4. So total we have 4 nodes in the circuit. Now if we want to write the KCL at node 1, what we have to write? We should assume that V1 is greater than V2 and V1 is greater than V3. That is the assumption. We have to apply KCL at node 1. Now if I apply KCL at node 1, I can calculate or I can write the current flowing through this resistor. What it will be? V1 minus reference node divided by 10 will be the current flowing through this resistor. Current flowing through this will be V1 minus V2 by 20. Now if I come to this branch, there is a voltage source. That is what yesterday we have told. This branch we have a voltage source and this voltage source is between two independent nodes where we have given the name node 1 and node 4. We can't write the current flowing through this branch, but if we want to apply KCL, we need to know in all the 3 branches. So what we do? We say that a super node is formed. We assume that we are shorting node 1 and node 4. This is node 1 and node 4. We are making it as a super node, means we are shorting those two. Now if we short those two, this branch won't be there. 1 and 4 are coming together. And so for node 1 we need to write current leaving this through this branch, current leaving through this branch, and then we have to consider these two branches, that is 5 ampere source and 12.5 ohm resistor. So all these 4 elements together will be one equation. Let us try to see that equation in the PPT. This is the super node equation, node 1 with node 4. Now if you see the equation, current flowing through this 10 ohms is you can see here V1 by 10 is the current flowing through 10 ohm resistor. V1 minus V2 divided by 20 is the second one, that is the current flowing through 20 ohm resistor, and then V4 minus V3 current flowing through this 12.5 ohm resistor is this term, and here there is a current source connected to node 4. So this current is entering the node, so that is with a negative sign. The first 3 terms, if you observe, it has the positive term because current is leaving the node, and through the current source current is entering the node 4, so it is with a negative sign. So we have written one super node equation formed with node 1 and node 4. Okay, so the same equation, if you separate the terms V1, V2, V3 and V4 terms, we have got the equation here, that is equation 1. Now coming to the Now coming to the equation node 2. Now node 2 and node 3 if you consider, there is one more voltage source in between these two. So if I want to write an equation, I cannot write the current flowing through node 2 to node 3 because there is a voltage source. Again there will be a super node forming between node 2 and node 3. So if I want to write the super node equation, I have to consider the three branches connected to node 2, that is 5 ampere current source, 20 ohm resistor, 25 ohm resistor, all three connected to node 2, plus for node 3 this 10 ampere current source and 12.5 ohms resistor. All 5 terms will be there in this equation. Now let us see the equation. V2 minus V1 by 20. The first term shows that current leaving node 2 and flowing towards node 1. Why current is flowing from node 2 to node 1? Now I am writing the equation, super node equation formed with node 2 and node 3. So my assumption will be node 2 V2 voltage is greater than V1, V2 voltage is greater than V4. So current will flow from node 2 to node 1 through 20 ohm resistor. That is what I have shown it as V2 minus V1 by 20. Now next one is current flowing from node 2 to the reference node through 25 ohms. So that is V2 by 25. Now one more current source is connected to node 2, that is 5 ampere current source. So current is leaving the node 2. So I should write with a positive sign. Current if leaves the node it is positive, current if it enters it is negative. So I have written 3 terms because 3 branches which are connected to node 2, the first 3 terms are that. Now the next is the elements which are connected to node 3. Now if I consider the elements connected to node 3, apart from this voltage source, we are thinking we are shorting this 150 volt source. So we are left out with this 10 ampere current source and 12.5 ohm resistor. So current 10 amperes through current source, 10 ampere current source, current is entering the node 3. So minus 10 in the equation, and current flowing through 12.5 if I consider, current leaves the node 3 and enters the node 4. Because I am writing equation at node 3, my assumption will be V3 is greater than V4. So current flows from V3 to V4, that is one slide over there. So current is flowing from V3 to V4, so that is V3 minus V4 divided by 12.5. This is the super node equation formed between node 2 and node 3. It is having 5 terms. You can see 3 elements are connected to node 2 and 2 elements are connected to node 3. Now here if you separate all these terms V1, V2, V3 and V4, you will get this equation. This equation, if you see, there are 4 variables V1, V2, V3 and V4. Now in the previous equation we have written super node forming between node 1 and node 4. There also we got 4 variables V1, V2, V3, V4. Here also we got V1, V2, V3 and V4. Now you have 2 equations with 4 unknowns. You cannot solve the equation if you have 4 unknowns with 2 equations. So you need to get 2 more equations. Those 2 equations are nothing but the voltage relation between the super nodes. Now if I consider the first super node is formed between node 1 and node 4. So if you see this, positive of this is connected to node 4 and negative of the source is connected to node 1. So I can write a voltage equation or a voltage relation between node 4 and node 1 as V4 minus V1. V4 minus V1 is equal to 100 volts. That is one equation. And the second equation I can write in terms of V3 and V2. Now V3, if I consider, V3 is connected to positive of this 150 volt source and negative of this is connected to node 2. So V3 minus V2 is equal to 150 volts. This is one more equation. these are the two equations. V3 minus V2 is 150, V4 minus V1 is 100 volts. So now we have total 4 equations. This is the first equation formed with supernode 1 and 4. This is the second equation, supernode equation formed with node 2 and node 3, and this is the voltage relation. These two equations are the voltage relation. So we have 4 equations with 4 unknowns. Now we can simplify these things, but if you have 4 variables, to solving this becomes little difficult. So instead of making it as 4 variable with 4 equations, let us try to make it as 3 variables with 3 equations. So if I consider this equation, that is V3 minus V2 is equal to 150, from this what I can write, V3 is equal to 150 plus V2. Just this equation alone I am rearranging it. V3 is equal to 150 plus V2. Now substitute wherever V3 is there in these equations, here, sorry, substitute with 150 plus V2. So what will happen? We will have the first equation in terms of V1, V2, V4, second equation V1, V2 and V4. Wherever V3 is there, we are replacing with V2. So we will get 3 equations. This will be the first equation, second equation, and this will be the third equation. 3 equations with 3 unknowns. So you can easily solve it either by Cramer's rule or use your calculator, keep it in the equation mode and enter all the coefficients, you can get the answer. So after substituting all those things and solving, we will get the value of V1, that is voltage at node 1, V1 to be 74.77 volts, voltage at node 2 is 63.06 volts, V4 will be 174.77 volts. Why we will get with these 3? Because we have reduced all the equations in terms of V1, V2 and V4. Now V3 is nothing but, we know that V3 is 150 plus V2. So 150 plus V2 if you add, you will get V3 value. That V3 value is 213.06. That is the voltage at node 3. Now what we have started with, the starting was, this was given as Vx. You have to find the value of Vx. Now what is Vx? We have solved this problem. We got the value of voltage at node 2. Vx is nothing but voltage between node 2 and the reference node. So Vx is equal to V2, the node 2 voltage, whatever we have got, that is equal to 63.06 volts. So voltage across 25 ohms is 63.06 volts. Now in this problem we have used supernode technique, because we had 2 voltage sources, one voltage source 100 volt source between 2 independent nodes and one more voltage source between independent nodes 2 and 3. So whenever you get a voltage source between 2 independent nodes, you have to use the supernode technique. Means you have to assume that you are shorting it and write the nodal equation at that particular supernode. Now whatever the answers we have got here, that is with respect to this node. We have taken this node as the reference. With respect to this V1 voltage we got, with respect to this reference node we got V2, with respect to this reference node we got V3. Suppose you change any one of the other nodes, suppose if I make this as my reference node and if I make V4 here, all the values will be different because my reference point is different. But when you want to calculate current flowing through any element, then it remains the same, because the reference point alone you are changing. Okay, so you can select any node as the reference node and you can solve it, and from that whatever is the asked thing you can get the answer from that. Now till now what we have seen in yesterday's class also, we have seen only with current sources, only with voltage source. Now let us try to solve something different. Now consider this particular problem. Now what are all there in this? What way this problem is, or this circuit is different than the previous one? Let us see here. We have one voltage source in series with a resistance. We have one more 3 volts voltage source in series with 2 ohm resistor. So, in the previous problem we didn't had resistance in series with a voltage source. Between two independent nodes we had only the voltage source, but here it is not the case. You have a resistance. In such case, how to write KCL and how to write those equations, let us see. Now, first we need to identify the nodes. Now, this is one node because 4 amperes current source, 4 ohms and 2 ampere current source all are meeting here. This you can consider as one node. This is the second node and this you can take as the third node, and this point is the fourth node, and one of the 4 you have to select as the reference node. Let us see what we have done. Now, I have selected the bottom one as the reference node. This top one is node 1, node 2 and node 3. 3 nodes are there. Bottom is the reference node. What I have to calculate? Let me see what we have to calculate. Determine the power supplied by 2 ampere source using nodal analysis. I need to find out power supplied by this current source using nodal analysis. So, as per the nodal analysis, first I have identified the 4 nodes. One node I have taken as the reference node. Remaining nodes I have given as the name V1, V2 and V3. Now, I have to apply KCL at node 1. If I want to apply KCL, I have to see how many elements are connected here. You can see that 4 ampere source and 4 ohm resistor and 2 ampere current source is connected to node 1. So, node 1 equation, 4 amperes is leaving the node. So, with a positive sign plus 4, and current flowing from node 1 to node 2 I have to consider now. Now, previously till now we had only the resistors. Now, we have a voltage source. Now, how to consider this voltage source? Now, look at this. Suppose if you do not have the voltage source, how do we calculate the current? V1 minus V2 divided by 4 we write. But we have a voltage source and negative of this voltage source is connected to V1. When we write the KCL equation at node 1, what we are telling? We are telling that V1 is at higher potential, some positive voltage is there. So, this positive voltage is connected to negative of one more source. Means what? This voltage is aiding this node voltage V1. So, if negative of the source is connected to V1, what I should write is V1 plus 1 volt, because that is adding to this node voltage. So, that is why the equation V1 plus 1 minus V2 divided by 4 gives me the current flowing through this branch. Is it clear? Let me repeat that. If we have a voltage source between node 1 and node 2 with a resistance in series, so I can calculate the current flowing through this branch. So, that is nothing but V1 minus V2 plus 1 volt, because negative of the 1 volt source is connected to the positive voltage of V1. That is the reason V1 plus 1 minus V2 divided by 4 gives me the current flowing from node 1 to node 2. Current will flow from node 1 to node 2 because node 1 is at higher potential. Because I am writing KCL at node 1, naturally this I have to assume this to be at higher potential. So, current leaves the node 1 and enters into node 2. So, that is why the whole term with a positive sign. Next is 2 ampere current source. Here also if you see the direction of the current source, 2 amperes is leaving the node. So, in the equation I have taken with a positive sign 2. So, 4 amperes is leaving like this, and through this branch current is leaving, that is V1 plus 1 minus V2 by 4, and here through current source plus 2 amperes. This is equal to 0 is the first node equation. So, whenever I have a resistance in series with a voltage source connected between 2 independent nodes, I can write the current flowing through this branch. So, a super node won't form here because I have a resistance, I can calculate the current flowing through this. So, that is the reason here this is not a super node, okay, because we have a resistance. Now, let us come to node 2. Now, node 2, if I see, there are 3 different branches connected to it, but if I consider here, there is a voltage source connected between reference and node 2. Now, what is the property of a voltage source? The property of the voltage source is to maintain this voltage 4 volts irrespective of the current whatever it supplies. So, this 4 volts always, this source 4 volt source always maintains between this point and this point 4 volts. So, it is fixed at node 2 always it will be 4 volts. So, I do not need to write any equation. In nodal analysis, what is our aim? Our aim is to first calculate all node voltages, and using those node voltages we will calculate current flowing through different branches of the circuit. Now, here at node 2 there is a voltage source connected between node 2 and reference. So, I do not need to write any equation. I can directly write that node 2 V2 is equal to 4. That is what is been written it here. V2 is equal to 4 volts. I do not need to write any equation. I do not need to write current flowing through this branch or through this branch. Nothing I do not need to write because I know the voltage here. So, directly I can write V2 is equal to 4. Then next comes the equation at node 3. Now, let us see at node 3 what are all connected. 3 branches are connected. This is first branch, second branch and third branch. So, I need to write whether the current is entering or leaving, everything I have to write. Now, consider this 1 ohm resistor. V3, I am writing equation at V3. So, V3 voltage is greater than any other node voltage. So, current will leave V3 and it will flow to the other node. So, this is the reference node. So, reference node is something like a 0 potential node. So, current will flow from V3 to the reference node. So, V3 divided by 1 is the current leaving the node 3 and flowing through this path. So, that is V3 by 1. Next is current flowing from node 3 to node 2 through this branch. Now, here also we have a voltage source. See the polarity. The negative of this 3 volt source is connected to node 3. Means what? This is positive voltage and this positive voltage is connected to negative. So, these two gets added up. So, V3 plus 3 minus V2 divided by 2 will be the current flowing through it. So, current flowing through this branch is V3 plus 3 minus V2 divided by 2. That is the second term what we have seen for the node 3. Now, the third branch is 2 ampere source. 2 ampere source is entering into the node 3. So, this current is entering. Whenever current enters the node, I will write it as minus sign, with a minus sign. So, the third term is with a negative sign, minus 2. So, if you see the 3 terms, all 3 terms we have written which are connected, all 3 branches which are connected to node 3, that is the equation, is equal to 0. So, we got 3 equations. Why we got 3 equations? Because we had 3 independent nodes. First node equation is this. Equation at node 2 we do not need to write because we have only voltage source. You can directly write V2 to be 4, and the third equation is at node 3. Now, if you consider the first equation, it is having the variables V1 and V2. Now, V2 value is 4. So, you can directly substitute 4 here and you can get the value of V1. So, you can get the value of V1 here. Coming to the third equation, V3 is unknown. V2 value is 4, substitute V2 value here, you will get V3 also. So, V1, V2, V3 all node voltages you can calculate and you can get the values. Now, let us see, in all these equations we have not come across this 3 ohm resistor. What has happened to this 3 ohm resistor? Now, when we have considered this particular branch, current flowing through this branch, when that is nothing but 4 amperes. Why it is 4 amperes? Because a current source is connected in series with this resistance. So, whatever may be the case, current flowing through this is fixed. So, in our equations, this 3 ohms has not come into picture because we are applying KCL. We want only the current flowing through this branch. So, that we have considered in node 1 equation. So, that is 4 amperes we have shown. So, this 3 ohms, even though it is there in the circuit, it will not reflect in any of the equations because this 4 amperes, same 4 amperes is flowing through this. So, this will not come into or in our equations. And one more thing what we can tell, this is a trivial element. We know the current flowing through it, so you can tell the voltage across that if you want, and it does not have much significance because the same 4 amperes has to flow through this 3 ohm resistor. Okay. So, we have 3 equations, we can solve all the 3. Let us see the values. Now, if you solve all the equations, V1 value, voltage at node 1, V1 is minus 21 volts, V2 volts, voltage at node 2 is 4 volts. We do not need to solve because it is already connected, a voltage source is connected. So, you do not need to solve it. V2 is equal to 4 volts and V3 is equal to 1.67 volts. What was the question asked? Find the power supplied by 2 ampere source using nodal analysis. So, using nodal analysis, we have found all 3 node voltages. Now, we have to find the power supplied by this 2 ampere current source. So, power supplied by this 2 ampere current source is nothing but we need to know the voltage difference between these 2 points. This current source is connected between node 1 and node 3. Now, let us see, node 3 is equal to, node 3 voltage is 1.67, whereas node 1 voltage is minus 21. So, node 3 is at higher potential than node 1. So, voltage difference between node 3 and node 1 is V3 minus V1. So, the net voltage is 22.67, voltage across the source current 2 amperes current source is 22.67. So, power supplied by this source is 22.67 into 2, that is equal to 45.34 watts. So, we have calculated the power supplied by the current source. So, in this problem what we have seen, the new thing what we have seen in this problem is, if you have a voltage source in series with a resistance, then you can write the current flowing through this particular branch. You do not need to consider this as a super node. You can just simply calculate, or you can write the expression for the current flowing through this resistor or through this branch. Now, let us go to the next type of problem, that is the with dependent sources. Till now whatever we have seen is with only independent sources, independent voltage source, independent current source we have seen super node technique. Now, let us see what is a dependent source, and with dependent source how to solve a given circuit using nodal analysis. This is very simple circuit. Now, let us see, this is a dependent voltage source. The polarities here shows that this is positive, this is negative. So, this is a dependent voltage source. Because the polarities have been mentioned, it is a voltage source. Suppose if you get an arrow mark here, means that will be the current source. So, this is a dependent voltage source, magnitude of it is 0.5 I1. Now, see, magnitude of it is 0.5 I1 means what? The magnitude of this dependent voltage source is dependent on this current I1. I1 is nothing but current flowing through this branch. Okay. So, magnitude of this voltage source is dependent on current. So, this is current dependent voltage source. Now, let us try to apply nodal analysis and try to calculate this value of I1. The problem given is determine I1 using nodal analysis. So, we have to find the value of I1 using nodal analysis. So, the first step is to identify number of nodes. All these 3 elements are connected in series. So, instead of connecting this, taking this as one node and this as one node, you do not need to consider that. If you consider this as a separate node and this as a separate node, then your number of equations increases. Other than that, nothing else will help you. So, instead of that, whenever you have elements connected in series, you do not need to take in between points as a separate node. As per the definition of a node, you can say 2 elements or more than 2 elements are connected, you can say it is a node. But because they are all connected in series, so you do not need to consider this point as a node or this as a separate node. So, all these 3 are connected in series. So, we will make this as one independent node, and I have considered the node name as A, because here it is already they have mentioned the current flowing through this branch as I1. So, instead of naming this node as 1, it is better to name it as A. So, this is node A, one node, and the another node, this is the second node, this is the reference node. In this side, if you consider this voltage source and resistance both are connected in series. So, I do not need to consider this to be a separate node. If you want, you can consider, but what happens if you consider that, you need to write one more equation there. So, without that you can, because these two are in series, whatever the current flows through this, the same current has to flow through the remaining part. So, you can just simply consider the whole branch as a single branch instead of having one more node here and one more node here. So, you can simplify your process. So, only two nodes, node A and reference node. Now, how many branches are connected to it? This is one branch, this is second branch and this is third branch. So, in my equation there should be three terms, first term, second term and third term. Now, let us see the equation how we can write this. Now, the first equation is, I want to write current flowing through this particular branch. So, in this branch what we have a voltage source, 4 volts voltage source, positive of it is connected to node A. So, node A, when I write equation at node A, my assumption is this is at higher potential, positive voltage. So, this positive is connected to positive of another source. So, both will be opposing. So, what I should write, VA minus 4 will be the voltage in this branch divided by 2 gives me the current flowing through this branch. VA minus 4 divided by 2 gives me the current flowing through this branch, through this 2 ohm resistor. Then this current source, if you see the current source direction is away from the node A. So, whenever current leaves the node, we are considering it as a positive term. So, plus 2, current leaving the node A, so plus 2 amperes. Then comes the third branch. If you come to this third branch, now what are all there, we will see. This is a voltage source, this is a dependent voltage source, this is also a voltage source. Now, this 3 volts voltage source, positive of it is connected or is towards node A, and positive of this dependent source is also towards node A. Both are towards node A. So, what I should write, VA minus 0.5 I1, because this voltage is opposing this, positive is connected to positive. So, I should write VA minus 0.5 I1 minus 3, because this positive is also connected to that. So, minus 3 whole thing divided with 4, because there is 4 ohm resistor here. So, VA minus 0.5 I1 minus 3 divided by 4 gives me the current flowing from node A through all these elements to reference node. That will be the third term. So, this is the equation. Because we have only one node here, we will get only one equation. But in this equation, if you observe, VA is our independent variable, but I1, a new independent variable, has come into picture. So, we need to replace this I1 with our independent variable VA. So, we need to know what is the relation. I1 is what? As per the circuit diagram, I1 is nothing but current flowing through this branch. That is what has been mentioned here. So, this is I1. This branch current is named as I1. So, I1 is equal to VA minus 4 divided by 2. That is your I1. VA minus 4 by 2 is I1. This branch current is named as I1. I1 is equal to this. So, now in this equation, wherever I1, here we have I1, you substitute this I1 with this equation, VA minus 4 by 2. So, if you substitute with that equation and rearrange all the terms, you will get this equation. Okay, here I1 has not been substituted, you have to substitute I1 with this VA minus 4 by 2 here. Here only they have separated IA terms, I1 term and the constant terms. That is all have been done here, but you have to substitute I1 value with this. If you substitute that and solve for, if you solve, then you will get the value of VA. Value of VA, that is voltage at node A, is equal to 0.727 volts with respect to this reference node. With respect to reference, this is 0.727 volts. What is our aim? We have to calculate I1. What we have to calculate is I1. So, I1 is equal to VA minus 4 by 2. VA minus 4 by 2 gives me the I1 value. I1 value is minus 1.636. So, they have shown the value of I1 direction like this, but this negative sign here, whatever we have got, it tells that actually current in this branch is flowing in this direction, opposite to it. The negative sign here tells that actually current is flowing in this direction. So, I1 value is minus because they have mentioned the direction. So, with respect to this direction, it is the negative sign. Okay. So, the magnitude of I1 is 1.636. Negative sign shows that actually the current is flowing in the opposite direction. So, we have applied nodal analysis to solve this problem with dependent source. So, whenever you have a dependent source, you will get one equation related to the magnitude of the dependent source. So, you can consider this voltage source as similar to any other voltage source. Only thing is magnitude of it is not a constant, but it will be dependent on any one variable, that may be a voltage or current based on the dependent voltage source given. Okay. So, we have seen all the different types of sources, how it can be connected in the circuit, and we have seen how to solve that. Very first type was connecting only with the independent current sources. Second type was with independent voltage source connected between two independent nodes, that was supernode technique. The third one was a voltage source connected in series, independent voltage source connected in series with a resistor, we have seen. And then the fourth type is with dependent sources. So, we have dealt with all different types of sources. Now, let us go to little more complicated problem where we have to apply all these things whatever we have seen till now. Nothing big here, whatever we have seen, the same thing we can apply to solve this. The problem is determine the node to reference voltages. This is the circuit given. Now, see this, we need to find all the node voltages with respect to reference voltages. So, one node we have to consider as reference node and remaining node voltages are the independent nodes. I have considered the center node as the reference node, and V1, V2, V3 and V4. There are total 5 nodes, center one is reference. So, with respect to reference, as per the problem, we have to calculate V1, V2, V3 and V4. Now, let us see how to write the equation, what are all there in this circuit. Now, this is the circuit, we have given the node names here because we have 4 independent nodes. So, 4 equations we have to write. Let us come to node 1. This is node 1. If you see node 1, actually 3 branches are connected to node 1, but out of this 3, there is one voltage source between reference and node 1. So, between reference and node 1, we have a voltage source. So, this voltage source, what it will do? It maintains the voltage constant between these two. So, no voltage at V1 is dependent on this source. Now, positive of this is connected to the reference node and negative is connected to V1. So, the voltage at node 1 is minus 12 volts because the magnitude is 12. So, it is 12, minus sign because positive of the source is connected to the reference and negative is connected to V1. So, that is the reason with a negative sign. So, you do not need to write any equation to this node. To see this problem, it looks more complicated, but it is not a complicated problem at all. V1 voltage, you do not need to write any equation, you know directly because there is a voltage source between the reference and node 1. So, V1 is equal to minus 12 volts. Now, coming to node 2. For node 2, there are again 3 branches connected, 2 resistors and 1 current source. It is a simple all the elements are simple elements, so you can easily write V2. So, current flowing through this branch V2 minus V1 divided by 0.5 ohms. Because we are writing the equation at node 2, our assumption is always V2 is greater than V1. So, current will flow from V2 to V1. If current leaves the node, it is positive. So, that is why V2 minus V1 divided by 0.5 ohms is current flowing through this branch. Next, current flowing from node 2 to node 3 through this 2 ohm resistor. So, V2 minus V3 divided by 2, that is the second term, V2 minus V3 divided by 2 is current flowing from node 2 to node 3 through this 2 ohm resistor. The third term in the equation is because of this current source. If you see the direction of the current source, arrow head is towards the node V2. So, current is entering into node 2. So, if current enters the node, I should take with the negative sign, that is the reason it is minus 14. So, the second node equation is V2 minus V1 by 0.5, that is current flowing through this branch, and current flowing through this branch will be V2 minus V3 divided by 2, and here current is entering, so it is minus 14. This is node 2 equation. Now, node 3. Let us see node 3. If I see node 3, 3 branches are connected to node 3, but out of that there is one voltage source which is connected between node 3 and node 4. This is a dependent voltage source. Polarities have been marked. So, this is a voltage source and the shape of it tells that it is a dependent source. So, this is a dependent voltage source. So, there is a voltage similar to your independent voltage source. If you have only voltage source, whether independent or dependent, if you have only voltage source between two independent nodes, then you have to consider that as a super node, because we can't write the current flowing through this branch. We can't write current flowing through this branch. So, you have to consider this as a super node. So, a super node will be formed between node 3 and node 4. Means what? You have to assume that you are shorting these two and then you have to write the super node equation. Now, let us, when we write the super node equation, this branch will not come into picture. So, only two branches are connected to V3. One is 0.5 Vx. This is a current source, dependent current source. There is an arrow mark here in the diamond shape element. So, this is a current source and shape tells that it is a dependent source. So, current is entering into node 2, magnitude is 0.5 Vx. The magnitude of this current source is dependent on voltage, but magnitude is 0.5 Vx. Current is entering. So, I have taken this on the left hand side. All other terms I am taking on the right hand side. Suppose if I take this to the right hand side, which will be with the negative sign, that is all. I have just shown it on the left hand side. So, current entering the node, this is current entering the node, and through this resistance current leaves. So, that is V3 minus V2, V3 minus V2 by 2 is current leaving the node, that is I have shown on the right hand side. Left hand side is the current entering the node, right hand side is the current leaving the node. Next, only through two elements to node 3 and here coming to node 4, two elements. That is what? One is 1 ohm resistor connected between V4 and reference. So, current leaves the node V4. So, V4 divided by 1. So, that has to be on the right hand side. Current leaving the node I have shown in the right hand side. So, V4 divided by 1 is current leaving the node, and through this resistor V4 minus V1. V4 minus V1 divided by 2.5 ohms. 2.5 ohms gives me the current leaving this node. So, through this branch current is leaving, through this 2 ohms is also current is leaving. So, 3 terms on the right hand side where current is leaving, that is equivalent to the total current entering the node, that is 0.5 Vx. Okay, this is super node equation. Now, we have written for the node 1 we do not need to write equation. So, we have directly written minus 12. For node 2 we have written the equation. So, it is in terms of V1, V2 and V3, and node 3 and node 4 together it forms a super node. We have written the equation for this also, that is in terms of V2, V3, V1, V4 and Vx. All these are the terms in the supernode equation. Now, we can have in terms of any equation V1, V2, V3 and V4. We should not have, or we cannot keep this Vx in the equation. This has to be replaced in terms of our independent variables V1, V2, V3 and V4. Okay. Now, let us write that. Now, what is Vx? Vx is nothing but, where is Vx? Vx is here. Vx is voltage, what it has been shown, positive sign towards node 2, negative sign towards node 1. So, this voltage across this resistor is named as Vx. So, Vx is nothing but V2 minus V1. Vx is nothing but V2 minus V1. Now, in the previous, yes, here this is the Vx. What is Vx? Vx is the voltage across this resistor, that is V2 minus V1. That is what you have to substitute here. Okay. So, if you substitute that here, you will get 3 equations, first equation, second equation, third equation in terms of V1, V2, V3 and V4. So, we need a fourth equation. Fourth equation is nothing but this supernode equation. Supernode equation is what? There is a voltage source between node 3 and node 4. Relating to that, we have to write a equation. So, that equation is V3 minus V4 is equal to 0.2 Vy. Why like that? Because positive is connected to node 3 and negative is connected to node 4. So, V3 minus V4 is 0.2 Vy. V3 minus V4 is 0.2 Vy. Again this Vy we do not want, we want to replace that Vy. What is Vy? Vy is nothing but, they have shown in the problem, voltage across this 2.5 ohms, with positive they are showing towards 4 and negative towards node 1. So, Vy is nothing but V4 minus V1. So, 0.2 Vy is nothing but 0.2 into V4 minus V1. V4 minus V1 is Vy, that is what has been named. Okay. Vy is V4 minus V1 and Vx is V2 minus V1. So, we got 4 equations, all 4 in terms of V1, V2, V3 and V4. Now, you have to solve these 4 equations. Out of that one equation you do not need to solve, because V1 value is directly given, we have directly written. So, 3 unknown variables, if you solve that, we will get V1 to be minus 12 volts, V2 is equal to minus 4, V3 is 0 and V4 is minus 2 volts. So, with respect to this reference, all these voltages are negative only and V3 is 0. So, we have found all the 4 node voltages with respect to reference. They have not mentioned which node has to be taken as the reference node, but we have considered the center one as the reference node. Now, if we change and take any other voltage as the reference, other node as the reference node, the values will be different, because with respect to that we will tell. Now, with respect to this reference, V1 is minus 12, V2 is minus 4, V3 is 0 and V4 is minus 2 volts. So, we have solved all the 4 node voltages. So, we have seen all different types of problems with different types of sources. Only thing is left out is with AC source. We have not solved a single problem with AC source, that we will see in the tomorrow's class, and we will go with for the another technique, a new technique to solve a given electric circuit in the next class. So, today's class we have seen with dependent sources, with voltage source in series with resistors, if it is given, how to write the current flowing through it. So, try to apply this nodal analysis to different types of electrical circuits, and get the hold of it, so that you will enjoy solving the circuit using this particular technique. Okay, thank you.